Okay, welcome to math for today. Our big idea for today's lesson is to learn to solve whole number subtraction equations. Same goal basically as yesterday, except we changed one word. So go ahead and write this down along with today's date and page number in your notebook. When you're ready, come back. Here's your warm-up for today. 4 questions. Should look very similar to what you did yesterday because that's exactly what it is. So go ahead and solve for x for each one. Come back when you're done. And don't forget to show your work. So remember, as we learned yesterday, we learned about that wonderful vocabulary word or phrase, inverse operation, where to solve for this, you have to do the opposite operation, which cancels out the one side and allows you to do that operation on the other side. So since all of these are addition, the inverse operation of addition is subtraction. So for number 1, you're going to subtract 7 from both sides. That cancels it out on the one side. You're left with x equals 22 minus 7 gives you 15. For number 2, to get rid of the 18, you subtract 18. Now it's gone. And now it's just x equals, and 105 minus 18 would be x equals 87. And for number 3, we get rid of the 9's, and you're left with x equals, and 16 minus 9 gives you 7. And then finally for number 4, you get rid of the 4, and it's just x equals. And now you're left with 23 minus 4, which is 19. So if you got 3 or 4 correct, so maybe 1 wrong or none wrong, what I want you to do is I want you to give yourself an air high five. So go up, raise real high, and come close. Oh, nice job. Let's get into some math here so we can see what we remember or what new knowledge we're going to learn today. All right, here are 2 of our past presidents of the United States, neither of which you were born for at any time. I was born during Reagan's era, but I'm not old enough to remember Roosevelt. So let's take a look at the problem it says here. When Theodore Roosevelt became president, he was the youngest president at the time and still is at this moment the youngest to take office at 42 years old. He was 27 years younger than Ronald Reagan, who was the oldest president to take office. So if we were trying to figure out how old Ronald Reagan is, what we're doing is we're trying to solve for the variable, and we're going to say A is Ronald Reagan's age. So to solve for it, we know the final answer is going to be 42. But yesterday, or last lesson, we worked on adding problems. This is a subtraction problem. So if we were to take Ronald Reagan's age minus 27, it would give us 42, but we don't know what his age is. So we have to use inverse operation of subtraction to solve this. And what's the inverse operation of subtraction? Addition. Correct. So let's take a look at what we learned yesterday, and we're going to use that same information again today, sort of. So recall that we noticed that addition and subtraction are inverse operations of each other. Yesterday we practiced subtracting from the inverse operation of addition. Today we're going to practice the inverse operation of adding from a subtraction problem. We also say we're undoing the work. And if you remember, I had the terrible Willy Wonka example that I tried to explain in the last lesson, which I apologize for. But I don't apologize for having a creative imagination. Shame on you for denying me that right. All right, back to math. So remember, our problem is A minus 27, Ronald Wilson's age minus the 27 years younger that Theodore Roosevelt was. So if we're using inverse operation, we're going to have to undo the minus 27 on this side by doing the opposite, which is addition. And when you do that, they cancel each other out because they become 0. But just like we learned with fractions, what you do to one side, you got to do to the other side. So we will add 27 to the other side. We're going to bring the 27 over past the equal sign to the other stop. So from here, then you add 42 and 27 together, and what do you get? 69. So how old was Ronald Reagan when he became president? He was 69 years old. Now, he was president for 2 terms, which means he was president for 8 years. So how old was he when he resigned his position? So let's take a look at some of these problems that I want us to practice. That's why it says practice at the top, to really reinforce our understanding of this inverse operation. So, like normal, I want you to copy down this problem step by step as I show you. What are we going to do? We're going to solve y minus 23, which equals 39. We're going to try to get y alone. So the first thing you do is you rewrite the problem, and then we're going to have to figure out what the inverse operation of subtraction is. So what's the opposite of subtraction? Addition. So if we're going to have negative 23 here, let's add 23. And that's like saying you owe me 23 bucks. When you pay me 23 bucks, how much do you owe me now? The answer is 0. So this is gone. But don't forget, you got to add 23 to the other side, because of what you do to one side, you got to do to the other. Both sides have to undo the subtraction. Okay? And when you add 39 together and 23 together, you get 62. Where does the y go? Y just comes down, so that then you have y equals 62. Now remember, how can we check our work? All you have to do is put what we found y to be, which is 62, in for y, and take 23 away from 62. As we can see, the two balance, and because they balance, 39 is equal to 39, 62 is the correct answer. So copy this down if you haven't, and then join me when you're ready. All right, so here's another problem I want you to try on your own. Come back when you have accomplished at least trying it. All right, let's see how you did. So if you're remembering the whole inverse operation, you're going to see that we have s minus 15. To undo the minus 15, we're going to have to add. But what is it that we're adding to both sides? It's the number that's connected with the s. It's 15. So we're going to subtract 15 from s. And because we have to undo the work, we're going to subtract 15 from the other side. So then you just bring down the s. And you bring down the equal sign, obviously. And then we just do a quick little subtraction. And you should get 63. Now, to make sure that it's correct, what do? We simply just check our work by putting 93. I think I subtracted. I wanted to add 93 and see if we get the right answer. So when you do 93 minus 15, you do get 78. So because both sides equal, that is correct. So the correct answer should have been 93. If you got that right, come over to me and give me a high five. Here's another one I want you to try on your own. Now it says z minus 3 equals 12. Give it a shot. Come back when you're done. Okay. So what is it that we're subtracting from z? We see that it's 3. Well, we're going to have to undo that math. So undo the subtraction. So that means we're going to have to add 3 to both sides. Now, what does that do to the negative 3 plus 3? It's gone. And we just bring down the c. The z. Sound like c. And then 12 plus 3 gives us 15. So z equals 15. And how do we check that? Put 15 back into the original problem of z minus 3, or 15 minus 3, and you should get 12, what you do. So, if you got that right, I want you to give yourself a pat on the back. All right, so we've made it to our box of thought. I want you to complete these 2 problems and then box it off. That's why I call it a box of thought. So number 1 says, tell whether the solution of b minus 14 equals 9 will be less than 9 or greater than 9. So will b be a number that's larger than the number 9 or less than the number 9? Without even trying to solve it yet, see if you can explain your reasoning. And then finally, explain how you know what number to add to both sides of an equation containing the subtraction. So how do you know what of the numbers you're actually going to add to both sides? I want to see if you know why you're doing what you're doing. When you're done, move on to the quiz. All right, so here's your quiz. 6 problems today. So you're trying to solve for x for 1, 2, 3, 4, and 5 by using inverse operation of subtraction, which by now you should know is addition. And number 6 says Susan is taller than James. The difference in their height is 4 inches. James is 62 inches, so how tall is Susan if she's taller than James? Tell me what her exact height is. That's it for today. We'll see you in the next lesson of the wonderful world of math.